So I came across an article that focuses on alcohol drinking and not the way you actually think about it. In terms of we human beings, we know our limit in terms of how much alcohol we can take and what the effects can be, as studies have shown for almost decades or more than decades, definitely. But in here, we have something quite interesting in terms of checking out alcohol levels in all those species. And according to this article here, it looks at fermentation and how that plays a key role in how species are able to consume ethanol or alcohols, and how these can either make or break some species. And this article focuses mainly on two species here. Now, in terms of one category of species, we have those that consume greater than 4% of ethanol and what impact that can have on those species. And it says that this can lead to impairment, or in this case for human beings, it can, when you're drinking too much of that, when you're driving, that can impair your vision or your orientation. And also toxicity levels are truly high because our body has a limit to how much the enzymes can break those ethanol or alcohol contents, and this is similar for other species as well. Now, on the other extreme end, this article shows a particular research and how this research checks out two species and increased the levels of ethanol to not just 10%, not 20%, not 30, not 40, not 50, 60, no, guess what? 80% in terms of ethanol content. And they checked out two species. One is the hornets, and the other they tested it out was honey bees. And looking at those two species, you're wondering, why did they pick those two species? Let's go back to the process of fermentation. Now, fermentation is the process where you use yeast or you use bacteria to break down sugar into ethanol, and this particular process is truly found in ripe fruits. And you might be wondering, why do ripe fruits tend to break down quickly? And essentially, according to this article, it says that some of these insects, when they are interacting with all these fruits, what ends up happening is that they have this yeast, of course, that are in their gut, and they tend to transmit it over to those fruits, and as a result of that, those fruits, they end up breaking down quicker than you think, and they subjected both of them to around 0 to 80% of ethanol sugar solution. Sugar in the sense that, hey, maybe the yeast that are in their gut will break the sugar down into more ethanol, and this particular carbon has isotopes in them so that they can trace the carbon broken down in that particular system. Now, what they observed was that the hornet actually had around 300 more carbon inhaled in the system than the honeybee, which is truly fascinating and incredible amount. And so this here implies that yes, honey bees are not really great advantage. They don't really take advantage of the potential of ethanol as energy source rather than that of what the hornets, because the hornets were much more able to break down the ethanol and also sugar into energy source, and this here has led to some interesting results in terms of the behavior, not only socially speaking among the bees and hornets, but also in terms of just their physical state. And this includes the following. In this case here, it says that for the hornets, it says that they lived out their typical lives when they consumed 80% of this alcohol. Now, if you're looking at this type of hornet, the specific one here is known as the Vespa orientalis, and it says that these particular hornets, they have a lot of these enzymes in their gut, and what ends up happening is that they possess multiple copies also in terms of the genes that are able to break down what the alcohol and this alcohol breakdown can allow these hornets to consume as much as possible. So there are not only external factors in terms of what is inside that has a symbiotic relationship with hornets, which are the yeast or particular bacteria that are in their gut, but most importantly, generically speaking, they are built for this particular high consumption of alcohol and breaking it down into waste products. Now, in terms of the type of enzyme that honeys actually have, this enzyme is called alcohol dehydrogenase gene, or in the gene that makes that enzyme is called that, and then the enzyme is they call it alcohol dehydrogenase. And so this here is an enzyme that is produced to break down alcohol quickly, and this here is an incredible adaptation features that have made hornets to evolve and survive in this kind of natural environment where they are eating or consuming nectar that has high contents of alcohol or fermented products that are from fruits. And so it's kind of impressive to see how that is of a great advantage for hornets in terms of the evolution of it, but not quite for the honeybees. And so quite impressive stuff right here. And this kind of has that parallels with we humans and E. coli, where we consume a lot of fiber, and some of these bacteria in our guts, they break them down into waste and also useful nutrients. On the other hand here, when you look at honeybees, what ended up happening is that they died when they were exposed to 80% of ethanol within 24 hours. And so this here, even though they had the presence of yeast and they have copies of enzymes for alcohol, this here is really fascinating that the honeybees weren't able to stake it out that longer compared to the hornets. So the reason is, what are the other factors that honeybees doesn't have that hornets do have, and how is this going to change our understanding about we humans and our limits into how much we can push that spectrum of alcohol consumption? And when you do some little research, you can see a couple of interesting results in terms of human studies, which are as follows. Now, first is that consuming alcohol that is 80%, like for example, when we expose it to the hornets and they seem to do just fine, can be extremely dangerous and cannot be recommended. Now, here are some risks associated with consuming high proof alcohol. And first is, when you're looking at proof, it says 80% around 160 proof. That is crazy. And so first is level 1 is immediate high or health risks, which are 1, severe intoxication, we have alcohol poisoning, we got irritation, we have unconsciousness. That is like high likelihood of passing out or losing consciousness. That is really crazy. Now, there is a long-term health risk where it's like when you continue to consume that much 80% levels of alcohol, here's what happens. 1 is organ damage, where you have long-term damage to the liver, to the heart, and all the vital organs. Another one says is that you have like addiction to it, where you have high risk of developing alcohol dependency or addiction. And mental health issue is a big one, definitely, which increases the risk of mental health disorders. Now, it says that consuming such high level proof alcohol can lead to life-threatening situations, so it definitely is crucial to drink responsibly and choose beverages with low alcohol content. So this is just for the human perspective, and it's kind of crazy how scientists are like, you know what, since we can't try this on humans because of this level of high risk, how about we try something a little bit more interesting like hornets and honeybees. And so in honeybees didn't do that well, which is unfortunate, but hornets seem to do just fine. And in this particular article here, a different article, it says that for the honeybees, the high levels of alcohol can be toxic to them, lead to increased mortality and withdrawal symptoms. Now, honeybees naturally encounter low levels of alcohol in fermenting nectar, but this bodies, and it's equipped to handle high concentrations. So pretty impressive here. And there are other side effects as well that was listed in some other article in terms of, for the honeybees, they do have like this high impairing of their motor functions, learning, and memory. So pretty much a little bit of a great parallels with we humans in terms of those levels of alcohol. So pretty impressive stuff right here in terms of our result. And other side note, in terms of human beings, our blood has a specific level of alcohol that it can handle, and this particular process that is the measure for humans, it says that it's called the blood alcohol concentration, BAC, and these levels go from low to moderate to high to very high BAC. And so looking at the low level, which is around 0.02% to 0.04%, it shows you have a mild impairment where you have a slight buzz, like feeling relaxed. Another condition might come up, or symptoms might be minor mood changes or a bit more social. Another one is where the next level is moderate level, which is around 0.05 to 0.1% in the blood. Now in here we have impairments, which are reduced judgment, we have slower reaction time, we got decreased motor skills, and we have over the top behavior. And in terms of the legal limits, in many places this particular BAC has to be around 0.08% in the legal limit for driving. So pretty interesting for that particular bar being set. Now when you get to the high BAC, which is around 0.12% to about 0.19%, this is where you have significant impairments, where you have slurring of your speech, we have memory problems, you got nasal vomiting and loss of coordination. And very high levels is around 0.25% to close to 0.3 or 0.4%. And this is where you have dangerous effects like risk of coma, we got severe alcohol poisoning, we got potential fatal outcomes. That is really crazy. And then lethal levels is like 0.4% and higher, and this is where you have severe alcohol poisoning, like vital functions like breathing and heart rate may shut down completely, that leads to death. So it's going to be interesting to see much more studies in terms of the enzymes that are able in the particular hornets that are genetically linked, and how that impacts why they are able to sustain that much levels, and which part of these cells, definitely of course liver, do have a huge role in terms of breaking those down, and also like kidneys in terms of the filtration systems for humans, and how is that, how those are parallels with that of the hornets, and how those hornets actually may give us some clues into how to not break our body system, but to live our life in moderation or avoid alcohol at all costs. But anyways, that is my thought about this particular article. It's really fascinating. Let me know your thought about this in the comment section down below. By that way, I can talk to you soon. Stay smart as always, and believe in yourselves.